So what we have depicted here is a reaction. I have a beaker. In that beaker, I have molecules. I have these purple molecules. I also have these blue ones. And if I were to just leave this beaker at room temperature in my laboratory, nothing is going to happen. These molecules aren't going to react with each other. But then if I add energy to this, if I were to heat it up, then I can get it to react. And so that's what we have over here. The energy is used to break these bonds, and then the bonds can reform to form different molecules. So we have a reaction here. Here are the reactants. Here are the products. And I'm also going to assume that as these new bonds form, it also releases energy. And what we're going to think about in this video is whether the energy that is released from this reaction is greater than or less than the energy that we put into it. And depending on the answer to that, we would label this as either an endothermic or an exothermic reaction. So let's think about this a little bit more. So if you have a system, and you might say, what's a system? Well, a system is really just a fancy way of saying the thing that you are focused on. And you can define that system in any which way. Here we will call our system this beaker that has the solution inside of it. So our system is going to include that, but it's not going to include the outside, the burner that we're using to create the heat. It's just that beaker. So this is the system in either situation. And then we could also label the things outside the system. We could call that the surroundings. Hopefully that's an intuitive thing to call it. And when we light the flame underneath this beaker, we're transferring energy from the surroundings into the system. The law of conservation of energy, which is also known as the first law of thermodynamics, tells us that energy can neither be created nor destroyed. So if we're getting energy into a system, it has to come from someplace. In this situation, the energy is coming from our surroundings. But as we know, we're not just putting energy into the system. When these new bonds are formed, it's also releasing energy. In a situation where it's releasing less energy than was put in, I'll do that with a less wide arrow like this. This we would call an endothermic reaction. Even though some is being released, on a net basis, you're putting more in than you are actually getting out. Now, if you had it the other way around, where if you had your system here and you're putting in a certain amount of energy into the system, but you're getting a lot more energy out of the system. I'll do that as a big arrow like this. That's an arrow, that's not a house. If you have a big arrow like this, well, now this we would call an exothermic reaction. Let me box these off so that we don't get confused. Now we can also understand this in terms of potential energy and how the reaction progresses. So on the horizontal axis, we'll call this reaction progress. Reaction progress. And then the vertical axis is potential energy. Now our system, before we start heating it up, our system is going to be at some potential energy. And maybe it's just happy right there. But then we start putting energy into the system. We're doing this right over here by lighting that burner under it. So as we put energy into the system, the potential energy goes up. And that energy is used to essentially break the bonds of these reactants. And then once those molecular parts are all free of each other, they can now reform new bonds. And if we're in an exothermic reaction, those new bonds are going to be at a lower potential energy than the original bonds of the reactants. So one way to think about it here is, at this phase, we are putting in energy. This is the energy we are putting into the system. And you can calculate it by thinking about this arrow. And then once those molecular parts reform, you are releasing energy. And so you could think of that height as the release of energy. And if you thought about what the net energy that gets released is, well, that's going to be the difference between the potential energy as you're entering into the reaction and then your final potential energy. So this distance right over here is the net energy, and in this case, it is the net energy that has actually been released from the reaction. So this right over here is an exothermic reaction. You might be wondering, well, what would an endothermic reaction look like? Well, in that situation, and I'll just draw it really fast, it would have the same labels on the chart. You would be putting energy in. So let's say you have some molecules, put energy in to break those bonds. The bonds are broken, and now things reform, but they get to a higher potential energy than you were before. So here, we're putting in a lot of energy. But then when we have new bonds forming, that's not quite as much as the energy that we put in. And so there's a net amount that we put in. The net amount that we put in is going to be the difference between that and that. It's going to be this height right over here. So this is exothermic, and this is endothermic right over here.